Today's lesson is 12.4, volume of prisms and cylinders, which is clearly the goal. Volume is what, right? It is a number of cubic units contained inside a solid, right? So basically we're filling the solid up now, whether that happens to be a cube like this one, a rectangular prism like we'll learn in a little bit, a cone, a cylinder, pyramid, sphere, etc. Okay, so cubic units means our labels are going to be units cubed. So if it's inches, inches to the third power, centimeters to the third power, meters to the third power, and so on. Okay. Next, we've got a couple postulates. The volume of a cube is side cube. Right? Side times side times side, and that's it. Volume congruence postulate is if we have two congruent polyhedra. Honestly, two congruent solids. Does not have to be polyhedra. You could have congruent spheres as well. Then they're going to have the same volume. Volume addition postulate says volume of basically a composite solid is the sum of all its non-overlapping parts. So if we had a semicircle on top of this, we would have to add the semicircle to the volume of a cube. Or if we had a pyramid on the bottom and then a cone on the top, we'd have to add all three of them together. Next, volume of a prism is capital B base times height. And again, some books may call this length times width times height for rectangular prisms specifically, but because we're not limited, it just says volume of a prism, we are going to do area of the base times the height. Most bases will be pretty simple. It is possible we'll run into a regular polygon for a base, then your area is half ANS, and all three of those values will be given to you. Moving on to a cylinder, same formula, but we know that a base of a cylinder is a circle, and the area of a circle is pi r squared. So pi r squared height, we only have radius and height to deal with then, and you just figure it out and plug them in. Maybe you have to divide by 2 if we're given a diameter instead of a radius, right? Moving on, find the volume of the solid. Now again, you get to choose which side is the base in this example, because if this was the base, this would be the height, right? 9 times 6, 9 times 8, that would give us the answer. If this bottom one was the base, 8 times 6 gives us this area, and then times 9 fills it up. Lastly, we could do, per se, the front side, this 8 by 9 rectangle, and then the 6 would be the height. Any of those three is okay because it's rectangular. Right? I'm not showing a bunch of right angles just to make you visibly see that it's rectangular, because right angles in a three-dimensional prism look a little funny. They actually would look not necessarily like a box, but a little different, because they would need to be parallel and perpendicular. Anyway, it's a little more confusing with that. But the more important part here is it is possible to have bases that aren't just rectangles. So that's why in this case it doesn't matter, because it's rectangular. Square base wouldn't matter. But when we get to like a trapezoid base or possibly a triangle base, then it would matter, because you couldn't just say the triangle's the height. So moving on, volume is base times height. I chose 8 times 6 to be my base, so 8 times 6 is the base, 9 is the height, and we get 432 centimeters cubed. Labels are extra important, as already emphasized, so make sure you keep track of those. Next, the volume of a solid. We've got a cylinder here, and again, try to, as you're going through these, remember, okay, what was this volume formula for this one? Because even if I give them to you, I won't tell you, oh, this is the cylinder formula. I'll just give you pi r squared height, and you would have to know, oh, that's got to be the cylinder. In this case, radius is 9, height is 6, so volume is pi r squared height, so pi times 9 squared times 6 gives us 81 times 6 is 486 pi, and using the pi button I get approximately 1526.81 feet cubed. Now again, if you don't have a calculator on hand, I highly recommend using the Desmos calculator, right? Desmos.com/scientific. If you need the link, I can post that below in the info. But basically, you've got your pi button right here, and they go plenty more than just 0.14. And so then in this case, times 486, and there's my answer, 1526.814. So that's why we did not round up. Okay, stayed at 0.81. Next, we've got words. Find the volume of a square prism that has a base edge length of 5 feet and a height of 12 feet. Now at first look, it may appear that we're missing something. We got length and height, where's our width? It's a square prism. So both length and width are 5. So volume equals base times height. Well, base is 5 times 5. So we're going to have this equals 5 times 5 times 12. Yeah, I could have multiplied it to 25, but I'm going to plug this in on the calculator anyway. Most of these calculations are a little beyond mental math. So 12 quarters is 300 feet cubed, right? Includes a label whenever they give you a label. Next example, we have another cylinder. Now this time we've got a line running all the way across, so that tells me it's a diameter. So we're going to need to do formula is pi r squared height, but we're going to need to divide 12 by 2 to get 6 for our radius. We've got radius, we've got height, plug it in. Pi times 6 squared times 16 gives you 576 pi, and again, plugging it in, 1809.76 meters cubed. Okay. Next problem. Now, this is where base matters. Okay, I see a trapezoid. Normally, if it looks like a trapezoid, it is a trapezoid. Okay. Why couldn't we call it a square prism? Well, then the other side is not going to be the same. We also don't have a height here. I mean, we have a height here. So usually that's your hint that, here's our solid. Now, to find the area of a trapezoid, right, what's the area of a base is half height times base 1 plus base 2. Well, this is our base 2. It's kind of hidden, so this would move up, and this would be 6 right here. 14 is the other base. 3 is our height of the base, right? Height of this piece, because this is also the height. Well, he said both were height. This is the height to find capital B. This is the H for the formula, just to be specific. So half 3 times 14 plus 6, which is just 20, times 3 is 60, divided by 2 is 30. So I get 30 for the base. Now I'm plugging in. Volume is 30 times 5, that's this value here, is 150. I see the label centimeters, so it's centimeters cubed. Now we've got a cylinder. Think about the formula. And you've got pi r squared height. So plugging it in this time, pi r is 2, height is 4, so 4 times 4 is 16 pi. It's going to be around 50.27 centimeters cubed. One last one. Volume of a right cylinder is given to us, 648 pi inches cubed, and the height is 18. Find the radius. Right, so again, we're using this formula because it's a cylinder, pi r squared height, filling in 18 for the height here, and filling in 648 pi specifically, so we don't have to worry about rounding. The pi's will cancel out in a second. So you see what I mean here? We've got 18 pi r squared. We're going to divide by 18 pi on both sides because we want r squared alone. So dividing by 18 pi, the pi's cancel. 18 goes into 648 36 times. So 36 is what number squared? That is 6. And so our radius is 6. Label was inches, so that label comes with. Right, not inches cubed because we're just finding radius. So the radius is 6 inches. We've got a Cavalari's principle, which basically means if two solids have the same height and the same cross-sectional area at every level, then they have the same volume. So the best way to think about this is think about a stack of CDs, even though we don't really use those much anymore. And if you pushed them all slightly over, did your surface change? Right? Did your volume change? Right? It's the same volume, but it just slanted a little bit. So in this case, like the height would change, and if we took a cross section and this went straight down, it would be the exact same as if this was straightened out. So we just do, okay, area of the base is half 9 times 5, height is 8, and so you're just plugging it in. Half 9 times 5 times 8, so that gives you 20 times 9, which I have 180 meters cubed. One last one is a reminder from an earlier problem that, hey, they were talking about the area of the volume addition postulate. Well, this is kind of the same idea as subtraction. If we find the whole volume and subtract these two holes, like a cylinder concrete block, sorry, not cylinder, but I was saying concrete block that has holes in it, we could find the area and then volume of the whole thing and then subtract the volume that these two holes would have. So the general idea is volume of the total is volume of the hole, right? 816.5 times 9 times 9, minus 2 of these volumes of the hole, because the holes are congruent, okay? So volume of the hole equals 16.5 times 9 times 9, which is 1336.5. Volume of the hole starting with H, each hole is 5 inch by 4.5 inch by 9. Multiplying those out to get 202.5, and then we're just going to plug it in. So 1336.5 minus 2 times 202.5, and I get a total answer of 931.5 inches cubed.